All right, boys and girls. Today we are going to be taking a look at section 13.2, probability distribution. A lot of the stuff that we look at in this section here should look pretty familiar because it's going to be some stuff that you looked at back in Math 1 last year. I'm sure you're all going to remember it super well. All right, so let's get started here. So first off here, we're talking about finding relative frequencies. Okay, the results of a survey of students' musical preferences are organized in this frequency table. What is the relative frequency of preferences for rock music? I'm sure this table is very representative of all of the students in your classroom and the types of music that they would prefer. If you remember, back in Math 1, we talked about frequencies and relative frequencies. Frequencies, if you recall, talked about a specific count or a specific number of something. We see that from this table here, that the frequency of people preferring classical music was 5. Frequency of those preferring rock music was 10. The relative frequency, though, dealt with a percentage or a fraction of the whole. So to find the relative frequency of preference for rock music, the first thing we need to find is how many total people or how many total students here were actually surveyed. Well, let's see. We have 10 plus 7, there's 17. 8 more, there's 25. Then 5, we have 30. Plus 6, 36. Plus 4, so we have a total of 40 students that were surveyed here. Now, how many of them preferred rock music? Well, there were 10 that had a preference for rock music out of 40 total. So 10 out of 40. We know that simplifies to 1 out of 4, which is the same thing as 25%. So our relative frequency for a preference for rock music is 1 out of 4, or 25%. All right, on this here, we have another example with the same table here. Now we are asking the relative frequency of preference for classical music. So why don't you go ahead and pause this video and figure this one out, and then come back and hit play after you get it. All right, hopefully you figured this one out on your own and you got that 5 out of 40 or 1 out of 8 is our relative frequency for classical, which is 12.5%. Okay, so here another question asking the same type of information here, still wanting to know relative frequency here. In this case, we are talking about a experiment that was conducted, tossing 3 coins or flipping 3 coins. And these are the results from that. We can see that on those 3 flips, there were 3 heads 5 times. Went heads, heads, tails 7, heads, tails, tails 9, and so on and so forth with the different flips there. So using the results below, what is the probability that exactly 2 heads will occur in the next 3 tosses? Okay, so probability, right? Again, finding that percent or that relative frequency that 2 heads, exactly 2 heads will occur. So we need to get our total again. So let's see how many total tosses we had here. Well, 5 plus 7 is 12. Then a 9, we get 21. And then 6, 27. Plus 2, 29, plus 9, 38, plus 10, 48, plus 2, 50. So our total here, the total out here, is 50. Now, how many times did we get exactly 2 heads? Well, the first one we had 3, so it's not exactly 2. There's exactly 2 heads. There, and here is exactly 2 heads. Here we have exactly 2 heads, and it looks like that is it. So we have 7 plus 6 plus 2, all out of our 50 total. So plus 6, 13, plus 2, 15 out of 50, which simplifies to 3 out of 10, which then gives us a probability of 30%. So based on this data, there is a 30% probability that exactly 2 heads will occur in the next 3 tosses. Kind of tying this back to your 13.1 section, this is relating to our experimental probability here, because this was a specific experiment that occurred, not theoretical. All right, so now we have another similar type of problem here. So again, read through this one and figure out that probability on your own. So go ahead and pause the video and see if you can figure that out there. All right, so again, we had to add them all up. Here there were 100 total. The frequency of spinning a 4 on the next spin happened 18 times. 18 out of 100 gives us a probability of 18%. Again, this is an experimental probability, and we actually see a student conducts a probability experiment, okay? Because we know if any of these events is equally likely occur, the probability, the theoretical probability of getting any of these numbers on the next spin is 25%, 1 in 4. But based on our experiment, this experimental probability is giving us that it is an 18% chance of us getting a 4 on the next spin. All right, now we got to make our own table from this data here. In a recent competition, 50 archers shot 6 arrows each at a target. 3 archers hit no bullseyes, 5 hit 1, 7 hit 2, 7 hit 3, 11 hit 4, and 10 hit 5. 7 hit 6 bullseyes. What is the probability distribution for the number of bullseyes each archer hit? Okay, so probability distribution is asking for the entire table. What is the probability of each individual event occurring? So let's set up our table here. So first off, we are going to have number of bull's eyes hit. All right, so that will be our first row. And then we have the frequency of each of those occurring. And then finally, we will have our relative frequency or our probability. Okay, here. So, number of bullseyes. Well, they had anywhere between 0 and 6 bullseyes. So, 0, 1, 2, 3, 4, 5, and 6. All right, now for frequencies, we've got to go back to our information there and find out. All right, so 3 archers, it tells us, hit no bullseyes. All right, so 3 hit 0. 5 hit 1 bullseye. All right, so there's 5. So I would say those 8, I'm not even sure you can actually call them archers. If they hit 0 or 1 bullseye, they definitely need some more practice. And then let's see, we got 7 hit 2. Tells us 7 hit 3. They're only a little bit better. All right, 11 hit 4 bullseyes. Now we're starting to get into some real archers here. 10 hit 5 bullseyes. And finally, 7 hit all 6 bullseyes in their 6 shots. And, interesting fact, out of those 7 archers that hit all 6 bullseyes, actually Mr. Fagan, Mrs. Helms, and myself were all in those 7 archers there. There were 4 other people that managed to match us, and we were 3 of those 7 that hit all 6 bullseyes on the arrow there. So just a little interesting fact for you. Okay, now back to the problem here. So now if we're talking about our probability distribution, we need to have our fraction or our percent of each of these probabilities here. Well, there were 50 total archers, it told us. So the probability that they hit 0 would be 3 out of 50, or 6%. And then we have 5 out of 50, or 10%. 7 out of 50, or 14%. Another 7 out of 50, again 14%. 11 out of 50, which would give us 22%. 10 out of 50, which is 20%. And finally, 7 out of 50, which is 14% again. All right, the other fact that we should recognize or know about with these probability distributions is as I look at my probabilities there, if I add up either in the fraction form or in the percent form, all of those, in the percent form I add all those up, it needs to equal 100. If I add up all of my fractions, all of my fractions there, it should total up to 1. All of my probabilities have to total up to 100%, which we know is a decimal, is the same thing as 1. That's what all of our probabilities on our distribution should always add up to. All right. On our last slide here, we have a similar type of problem where we want the probability distribution. Again, go ahead and pause the video, work through this one on your own, and then come back and see how you did. All right, go ahead and check your answer there. Hopefully you got what I got there for the frequencies and the probability distribution for these scores on a test. All right, hopefully you enjoyed this and learned a little something. Have a great day.